Hi friends, we are in chapter 4 and we're going to talk about the coordinate plane. Our vocabulary today requires a visual, so I've drawn this X and Y axis and we'll talk all about this. I think you guys have seen this before, but we're going to kind of act like you haven't and at least give you a little bit of a refresher. So you know that we have a way to locate points in a way, or to locate to pinpoint locations, and sometimes we use these things called axes. Okay, so the word axes refers to these lines here. So later on I'll tell you now, this is the y-axis and this is the x-axis. Y-axis and x-axis are always oriented this way. They do not switch. And another thing that we want to do is recognize that the numbers coming from this center point, that center point, by the way, is called the origin. The numbers that originate on the x-axis, that's what this is here, the numbers that originate on the x-axis increase to the right and decrease to the left. So we start at 0 and we go all the way up to as far as we want to go, and same thing in the other direction. So notice we've got positive numbers going to the right and negative numbers going to the left. Similarly, on the y-axis, our positive numbers are going up and our negative numbers are going down, again from the origin. So the origin is a location on our graph, and that location has a ordered pair that refers to it being at 0 on the x-axis and 0 on the y-axis. So the origin is located at 0, 0. It's the intersection of the two axes. This whole thing that we have here is actually, let me not use that, this whole thing, this whole feature, this whole drawing is called the coordinate plane. And so I'll just go around and circle and put a box on this whole thing. It's called the coordinate plane, and it doesn't end. It goes on forever and ever, infinitely in each direction, and that's why I've got the arrows there. So that's our coordinate plane. The next thing we want to define strictly is the x-axis, and we were just talking about that, so I'll do the x-axis first. So the x-axis is exactly what we talked about before, going left and right. And the y-axis over here, let's use maybe green, the y-axis is going to go up and down. All right, that's our y-axis. Our x-coordinate, well, let's talk about coordinates and what's going on here. So what we have is we can find points. We can pinpoint a location. So I can say this location here on my graph is at +5, -4. So I would write that as an ordered pair, 5, -4. And what I want you to notice is that the x term always comes first, just like in the alphabet, and the y term comes afterward. So it's an XY ordered pair. That's what's going on there, all right? So now that we've got that together, the x coordinate is considered the x part of that coordinate pair, right? So let's use a little highlighting magic here and say that the x coordinate is located here, and this is also an x coordinate, right? It's the first term. And the y coordinate, let's get that going on. The y coordinate is going to be this second one, the second point or location there. And so quadrant and graph, this whole thing is broken down into 4 different quadrants. This first quadrant is where everything is positive. All of the ordered pairs would be positives. So this is called quadrant 1. And we go counterclockwise to name the other ones. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So there we are, we've defined quadrants. And finally, graph. Graph is the placing of numbers, or of the placing of points and dots and lines and other figures on the coordinate plane. All right, so it's the placement of, and so we would call that graphing a point. So graph the point, we might be asked to graph the point 2, 3. And so we go over to 2 on the x-axis, 3 on the y, and say, okay, there's the point 2, 3. All right, hopefully that made sense. Let's go ahead and take a look at some examples. Here in example 1, we are asked to write the ordered pair for G. So we go to G, right there, and we figure out how far over on the x-axis and how high up on the y-axis. So the ordered pair, or the location of G, is at -4, 3. Here in example 2, we're asked to write the ordered pairs of A, B, C, and D, then name the quadrant in which each point is located. So the point A, let's go ahead and put it here. Point A, B, C, and D. The x-coordinate of A is out here on 1, 2, 3, 4. When there's no numbers given, you can assume that we're counting by 1, but we're not always counting by 1, so that's something you want to be careful of. But when there's no numbers given on the indications here, you want to just assume we're counting by 1. So anyway, the x-coordinate of A is 1, 2, 3, 4. The y-coordinate is 1, 2, 3. The ordered pair would be written as 4, 3, and it's in quadrant 1. Why don't you take a moment to pause me and try and see if you can come up with the answers to the other one. I hope you paused it and tried. Here are the answers that I would get for each of these, and I don't think any of them are particularly tricky. Just make sure your answers are the same, and if you're having trouble, let me know and we can talk about it a little more. Let's look at the next example. So for example 3, we're just going to be graphing some points. And one of the things you want to make sure and do, and I'm not able to do it as well as you guys can, is you want to draw really nice straight lines, and you want each of your spaces where your numbers are going to be represented evenly spaced. But you also want to take a look at the data points that you're going to be graphing, right? Take a look at those points. Make sure you know that if your x value goes to -4, and your highest x value goes to like +3, make sure that that is accommodated in your graph. That's going to be important because you don't want to start, oh, let me add a little bit more, So take a look at your data first. So let's go ahead and graph quickly. We're not even quickly, take our time. We're going to graph -4, +1. So we start at the origin, move back 4, 1, 2, 3, 4. And that's at -4. And +1 is up 1 right here. So that will be R. S is located at 0, so don't move left or right, and go down -5. 1, 2, 3, 4, and 5. So right there on the y-axis, that's where S is. And then T is going to be 3 spaces to the right on the x-axis, and then 2 spaces down, 1, 2. So we find ourselves here for T. And I think, do we have a D? Nope, that's it. So that's it for this example. Let's look at the next one. This example shows the coordinate system kind of in action. And so we know that when we see things on a map, they have a longitude and a latitude orientation. So we can literally, and if you played with Google Earth, you might see the longitude and latitude location of any of the places that you might zoom into and go, which is kind of fun. So we're going to look at longitude and latitude as we do with our ordered pairs. And so let's look at a couple of questions here. Oh, well, let me read. Latitude and longitude lines form a system of coordinates to designate locations on Earth. Latitude lines run east and west and are the first coordinate of the ordered pair, kind of like X, right? And longitude lines run north and south and are the second coordinate of the ordered pair. So the first thing we need to do is name the city at 40 degrees and 105 degrees. So let's go ahead. So we look for 40 degrees. Along the latitude, right? We look for 40 degrees along the latitude, and we find it here. Let's see if I can hold on. We find it there, and then we come over and we're looking for 105 degrees. So slowly, slowly taking our time, getting over, and we find that at 40 degrees and 105 degrees, 40 degrees longitude, 105 degrees latitude, we find Denver. The next question asks us to estimate the latitude and the longitude of Washington, D.C. So here's D.C. around here, and estimate the latitude. So we see that this is 40, and this is going down to 35. Looks like we're at what? What would you say this line would be? I'm looking at that line, realizing that this is only 5. I'm saying 41 or 42. Let's say 41 and a half. All right, so I think our latitude is at 41.5 and our longitude, so let's come over and see where the line goes through that point. Doesn't exactly, but we're between 75 and 85. And I feel like we're pretty much, let's see, let me look at, we're a little closer to 75, but we're kind of in the middle. So I'm going to go with 76 and a half. So 76.5. And we should put degrees in for here for each of them. So you can see that there is some application in the real world with our coordinate plane. Look, that's all for me. I want you guys to take care. Let me know if you have any questions and let me know if there's anything I can share with you. All right, bye-bye now.